I have to track every single one of these. And it was a madhouse back then there were 20 different video card vendors with all slightly different implementations of their non-standard functionality. So either I needed to natively program all of the VGA cards there to map in that memory and keep scrolling down through all of that. Or I kind of punted and took the easy solution of when you finally did run to the edge of the screen, I accepted a hitch and just copied the whole screen up there. So on some of those cards, it was a compatibility mode. In the normal ones, when it all worked fine, everything was just beautifully smooth. But if you had one of those cards where it did not wrap the way I wanted it to, you'd be scrolling around, and then eventually you'd have a little hitch where 200 milliseconds or something that was not super smooth.
As it froze a little bit. And so it's a binary thing. Is it one of the standard screens or is it one of the weird ones, the super VGA ones?
Yeah.
Okay.
And so we would default to, and I think that was one of those that changed over the kind of course of deployment, where early on we would have a normal mode, and then you would enable the compatibility flag if your screen did this crazy flickery thing when you got to a certain point in the game. And then later, I think it probably got enabled by default as just more and more of the cards kind of did not do exactly the right thing. And that's the two-edged sword of doing unconventional things with technology, where you can find something that nobody thought about doing that kind of scrolling trick when they set up those cards. But the fact that nobody thought that was the primary reason, when I was relying on that, then I wound up being broken on some of the later cards.
Let me take a bit of a tangent, but ask you about the hacker ethic, because you mentioned shareware. It's an interesting world, the world of people that make money, the business, and the people that build systems, the engineers. And what is the hacker ethic? You've been a man of the people, and you've embodied at least a part of that ethic. What does it mean? What did it mean to you at the time? What does it mean to you today?
So Stephen Levy's book, Hackers, was a really formative book for me as a teenager. I mean, I read it several times, and there was all of the great lore of the early MIT era of hackers, and, ending up at the end with, it kind of went through the early MIT hackers and then the Silicon Valley hardware hackers and then the game hackers in part 3. And at that time as a teenager, I really was kind of bitter in some ways. Like, I thought I was born too late. I thought I missed the window there. And I really thought I belonged in that third section of that book with the game hackers. And they were talking about, the Williams at Sierra and Origin Systems with Richard Garriott. And it's like, I really wanted to be there. And I knew that was now a few years in the past. It was, it was not to be. But the early days, especially the early MIT hacker days, talking a lot about this sense of the hacker ethic, that there was this sense that it was about sharing information, being good, not keeping it to yourself, and that it's not a zero-sum game, that you can share something with another programmer and it doesn't take it away from you. You then have somebody else doing something. And I also think that there's an aspect of it where it's this ability to take joy in other people's accomplishments, where it's not the cutthroat bit of like, I have to be first, I have to be recognized as the one that did this in some way, but being able to see somebody else do something and say, holy shit, that's amazing, and just taking joy in the ability of something amazing that somebody else does. And the big thing that I was able to do through id Software was this ability to eventually release the source code for most of all of our really seminal game titles. And it was a stepping stone process where we were kind of surprised early on where people were able to hack the existing games. And of course, I had experience with that. I remember hacking my copies of Ultima, so I'd give myself, 9999 gold and raise my levels and, break out the sector editor. And so I was familiar with all of that. So it was with a smile when I started to see people doing that to our games. I am, making level editors for Commander Keen or hacking up Wolfenstein 3D. But I made the pitch internally that we should actually release our own tools for like what we did, what we used to create the games. And that was a little bit debatable about, we'll give people a leg up. It's always like, what's that going to mean for the competition?
Yeah.
But The really hard pitch was to actually release the full source code for the games, and it was a balancing act with the other people inside the company. Where it's interesting how the programmers generally did get, certainly I am the people that I worked closely with, they did kind of get that hacker ethic bit where you wanted to share your code. You were proud of it. You wanted other people to take it and do cool things with it. But interestingly, the broader game industry is a little more hesitant to embrace that than like the group of people that we happen to have at id Software, where it was always a little interesting to me seeing how a lot of people in the game modding community were very possessive of their code. They did not want to share their code. They wanted it to be theirs. It was their, claim to fame. And that was much more like what we tended to see with artists, where, the artists understand something about credit and wanting it to be known as their work. And a lot of the game programmers felt a little bit more like artists than like hacker programmers, in that it was about building something that maybe felt more like art to them than the more tool-based and exploration-based kind of hacking culture side of things.
Yeah, it's so interesting that this kind of fear that credit will not be sufficiently attributed to you.
And that's one of the things that I do bump into a lot, because I try not to go claim. I mean, it's easy for me to say because so much credit is heaped on me for the id Software side of things. But when people come up and they want to pick a fight and say no, it's like that wasn't where first person gaming came from. And you can point to some of like things on obscure titles that I was never aware of, or like the old Play-Doh systems, or each personal computer had something that was 3D-ish and moving around. And I'm happy to say it's like, no, I mean, I saw Battlezone and Star Wars in the arcades. I had seen 3D graphics. I had seen all these things there. I'm standing on the shoulders of lots of other people, but sometimes these examples they pull out, it's like, nah, I didn't know that existed. I mean, I had never heard of that before then. That didn't contribute to what I made, but there's plenty of stuff that did. And, I think there's good cases to be made that obviously Doom and Quake and Wolfenstein were formative examples for what everything that came after that, but I don't feel the need to go fight and claim primacy or initial invention of anything like that. But a lot of people do want to.
I think when you fight for the credit in that way, and it does go against the hacker ethic, you destroy something fundamental about the culture, about the community that builds cool stuff. I think credit ultimately, so I had this sort of, there's a famous wrestler in freestyle wrestling called Buvai Sarsatia, and he always preached that you should just focus on the art of the wrestling and let people write your story however they want. The highest form of the art is just focusing on the art, and that's something about the hacker ethic, is just focus on building cool stuff, sharing it with other cool people, and credit will get assigned correctly in the long arc of history.
Yeah, and I generally think that's true. And you've got like there's some things there's the graphics technique that got labeled Carmack's reverse. I am, literally named it. And it turned out that I wasn't the first person to figure that out. Yeah. Like most scientific things or mathematical things, you wind up, it's like, oh, this other person had actually done that somewhat before. And then there's things that get attributed to me, like the inverse square root hack that I actually didn't do. I flat out, that wasn't me. And it's like, it's weird how the mimetic power of the internet, I cannot
like the Mark Twain of programming.
Yes.
It's just everything just gets attributed to you now, even though you've never sought the credit of things. I mean, but part of the fact that the humility behind that is what attracts the attributions. Let's talk about a game. To me, one of the greatest games ever made. I know you could talk about Doom, Quake, and so on, but to me, Wolfenstein 3D was like, whoa. It blew my mind that a world like this could exist. So how did Wolfenstein 3D come to be in terms of the programming, in terms of the design, in terms of some of the memorable technical challenges? And also, actually, just something you haven't mentioned is, how did these ideas come to be inside your mind? The adaptive side-scrolling, So the solutions to these technical challenges.
So I usually can introspectively pull back pretty detailed accounts of how technology solutions and design choices on my part came to be, where technically we had done 2 games, 3D games like that before, where Hover Tank was the first one, which had flat shaded walls, but did have the scaled enemies inside it. And then Catacombs 3D, which had textured walls, scaled enemies, and some more functionality like the disappearing walls and some other stuff. But what's really interesting from a game development standpoint is those games, Catacombs 3D, Hover Tank, and Wolfenstein, they literally used the same code for a lot of the character behavior that a 2D game that I had made earlier called Catacombs did, where it was an overhead view game, kind of like Gauntlet. You're running around and you can open up doors, pick up items, basic game stuff. And the thought was that this exact same game experience, just presented in a different perspective, it could be literally the same game, just with a different view into it, would have a dramatically different impact on the players.
So it wasn't a true 3D. You're saying that you
The
could kind of
game
fake it. You can like scale enemies, meaning things that are farther away. You can make them smaller.
So from the game was a 2D map. Like all of our games use the same tool for creation. We use the same map editor for creating Keen as Wolfenstein and Hover Tank and Catacombs and all this stuff. So the game was a 2D grid made out of blocks. And you could say, well, these are walls. These are where the enemies start. Then they start moving around. And these early games like Catacombs, you played it strictly in a 2D view. It was a scrolling 2D view, and that was kind of using an adaptive tile refresh at the time to be able to do something like that. And then the thought that these early games, all it did was take the same basic enemy logic, but instead of seeing it from the God's eye view on top, you were inside it and turning from side to side, yawing your view and moving forwards and backwards and side to side. And it's a striking thing where you always talk about wanting to isolate and factor changes in values. And this was one of those most pure cases there where the rest of the game changed very little. It was our normal kind of change the colors on something and draw a different picture for it, but it's kind of the same thing. But the perspective changed in a really fundamental way. And it was dramatically different. I can remember the reactions where the artist, Adrian, that had been drawing the pictures for it, we had a cool big troll thing in Catacombs 3D, and we had these walls that you could get a key and you could make the blocks disappear. Again, really simple stuff. Blocks could either be there or not there. So our idea of a door was being able to make a set of blocks just disappear. Mm-hmm. And I remember the reaction where he had drawn these characters and he was slowly moving around, and like people had no experience with 3D navigation. It was all still keyboard. We didn't even have mice set up at that time, but slowly moving, going up, picked up a key, go to a wall, the wall disappears in a little animation, and there's a monster like right there, and he practically fell out of his chair. It was just like, ah! And games just didn't do that. You know, the games were the God's eye view. You were a little invested in your little guy. You can be like, you know, happy or sad when things happen, but you just did not get that kind of startle reaction.
You weren't inside
something is your
game.
face, something in the back of your brain, some reptile brain thing is just going, oh shit, something just happened. And that was one of those early points where it's like, yeah, this is going to make a difference. This is going to be powerful and it's going to matter.
Were you able to imagine that in the idea stage or no?
So not that exact thing. So again, we had cases like the arcade games Battlezone and Star Wars that you could kind of see a 3D world and things coming at you, and you get some sense of it, but nothing had done the kind of worlds that we were doing and the sort of action-based things. 3D at the time was really largely about these simulation thoughts. Mm-hmm. And this is something that really might have trended differently if not for the id Software approach in the games, where there were flight simulators, there were driving simulators, you had like Hard Driving and Microsoft Flight Simulator, and these were doing 3D and general purpose 3D in ways that were more flexible than what we were doing with our games, but they were looked at as simulations. They weren't trying to necessarily be fast or responsive, or letting you do kind of exciting maneuvers, because they were trying to simulate reality and they were taking their cues from the big systems, the Evans and Sutherlands and the Silicon Graphics that were doing things. But we were taking our cues from the console and arcade games. You know, we wanted things that were sort of quarter eaters that were doing fast paced things that you could smack you around rather than just smoothly gliding you from place to place. So,
Quarter
yeah.
eaters.
And the funny thing is,
Yeah.
so much that built into us that Wolfenstein still had lives, and you had like one of the biggest power-ups in all these games, like was an extra life because you started off with 3 lives and you lose your lives and then it's game over. And there weren't save games in most of this stuff. It sounds almost crazy to say this, but it was an innovation in Doom to not have lives. You could just play Doom as long as you wanted. You just restart at the start of the level. And why not? This is like, we aren't trying to take people's quarters. They've already paid for the entire game. We want them to have a good time. And you would have some old timer purists that might think that there's something to the epic journey of making it to the end, having to restart all the way from the beginning after a certain number of tries. But no, more fun is had when you just let people kind of keep trying when they're stuck rather than having to go all the way back and learn different things.
So you've recommended the book Game Engine Black Book Wolfenstein 3D for technical exploration of the game. So looking back 30 years, what are some memorable technical innovations that made this perspective shift into this world that's so immersive that scares you when a monster appears? What were some things you had to solve?
So one of the interesting things that come back to the theme of deadlines and resource constraints, the game Catacombs 3D, we were supposed to be shipping this for Gamer's Edge on a monthly cadence, and I had slipped. I was actually late. It slipped like 6 weeks because this was texture mapped walls, doing stuff that I hadn't done before. And at the 6-week point, it was still kind of glitchy and buggy. There were things that I knew that if you had a wall that was like almost edge on, you could slide over to it and you could see some things freak out or vanish or not work. And I hated that. But I was up against the wall. We had to ship the game. It was still a lot of fun to play. It was novel. Nobody had seen it. It gave you that startle reflex reaction. So it was worth shipping, but it had these things that I knew were kind of flaky and janky and not what I was really proud of. So one of the things that I did very differently in Wolfenstein Catacombs used almost a conventional thing where you had segments that were one-dimensional polygons, basically, that were clipped and back-faced and done kind of like a very crude 3D engine from the professionals, but I wasn't getting it done right. I was not doing a good enough job. I didn't really have line of sight to fix it right. There's stuff that, of course, I look back, it's like, oh, it's obvious how to do this, do the math right, do your clipping right, check all of this, how you handle the precision. But I did not know how to do that at that time. And
was that the first 3D engine you wrote, Catacombs 3D?
And Hover Tank had been a little bit before that, but that had the flat shaded walls. So the texture mapping on the walls was what was bringing in some of these challenges that was hard for me, and I couldn't solve it right at the time.
Can you describe what flat shading is and texture mapping?
So in the walls were solid color, one of 16 colors in Hover Tank. So that's easy. It's fast. You just draw the solid color for everything. Texture mapping is what we all see today, where you have an image that is stretched and distorted onto the walls or the surfaces that you're working with. And it was a long time for me to just figure out how to do that without it distorting in the wrong ways. And I did not get it all exactly right in Catacombs, and I had these flaws. So that was important enough to me that rather than continuing to bang my head on that when I wasn't positive I was going to get it, I went with a completely different approach for figuring out where the walls were, which was a ray casting approach, which I had done in Catacombs 3D. I had a bunch of C code trying to make this work right, and it wasn't working right. In Wolfenstein, I wound up going to a very small amount of assembly code. So in some ways, this should be a slower way of doing it, but by making it a smaller amount of work that I could more tightly optimize, it worked out, and Wolfenstein 3D was just absolutely rock solid. It was, nothing glitched in there. The game just was pretty much flawless through all of that, and I was super proud of that. But eventually, like in the later games, I went back to the more span-based things where I could get more total efficiency once I really did figure out how to do it. So there were two sort of key technical things to Wolfenstein. One was this raycasting approach, which you still, to this day, you see people go and say, let's write a raycasting engine because it's an understandable way of doing things that lets you make games very much like that. So you see raycasters in JavaScript, raycasters in Python, people that are basically going and re-implementing that that approach to taking a tiled world and casting out into it. It works pretty well, but it's not the fastest way of doing it.
Can you describe what raycasting is?
So you start off and you've got your screen, which is 320 pixels across at the time if you haven't sized down the window for greater speed. And at every pixel, there's going to be an angle from you've got your position in the world, and you're going to just run along that angle and keep going until you hit a block. So up to 320 times across there, it's going to throw a cast array out into the world from wherever your origin is until it runs into a wall, and then it can figure out exactly where on the wall it hits. The performance challenge of that is, as it's going out, every block it's crossing, it checks, is this a solid wall? Mm-hmm. So that means that in like the early Wolfenstein levels, you're in a small jail cell going out into a small hallway. It's super efficient for that because you're only stepping across 3 or 4 blocks. But then if somebody makes a room that covers, our maps were limited to 64 by 64 blocks. If you made one room that was nothing but walls at the far space, it would go pretty slow because it would be stepping across 80 tile tests or something along the way.
By the way, the physics of our universe seems to be computing this very thing. So this maps nicely to the actual physics of our world.
Yeah, you get
intuitively.
I follow a little bit of some like Stephen Wolfram's work on interconnected network information states of that, and it's beyond what I can have an informed opinion on, but it's interesting that people are considering things like that and have things that can back it up. Yeah, there's whole different sets of interesting stuff there.
So Wolfenstein 3D had raycasting.
So the raycasting, and then the other kind of key aspect was what I called compiled scalars, where the idea of you saw this in the earlier classic arcade games like Space Harrier and stuff, where you would take a picture, which is normally drawn directly on the screen, and then if you have the ability to make it bigger or smaller, big chunky pixels or fizzily small drop sampled pixels, that's the fundamental aspect of what our characters were doing in these 3D games. You would have, it's just like you might have drawn a tiny little character, but now we can make them really big and make them really small and move it around. That was the limited kind of 3D that we had for characters. To make them turn, there were literally 8 different views of them. You didn't actually have a 3D model that would rotate. You just had these cardboard cutouts. But that was good enough for that startle fight reaction, and it was kind of what we had to deal with there. So a straightforward approach to do that, you could just write out your doubly nested loop of you've got your stretch factor, and it's like you've got a point, you stretch by a little bit. It might be on the same pixel, it might be on the next pixel, it might have skipped a pixel. You can write that out, but it's not going to be fast enough, where especially you get a character for that right in your face monster covering almost the entire screen. Doing that with a general purpose scaling routine would have just been much too slow. It would have worked when they're small characters, but then it would get slower and slower as they got closer to you until right at the time when you most care about having a fast reaction time, the game would be chunking down. So the fastest possible way to draw pixels at that time was to, instead of saying, I've got a general purpose version that can handle any scale, I used a program to make essentially 100 or more separate little programs that was optimized for, I will take an image and I will draw it 12 pixels tall. I'll take an image, I'll draw it 14 pixels tall, up by every 2 pixels even for that. So you would have the most optimized code so that in the normal case where most of the world is fairly large, like the pixels are big. We did not have a lot of memory. So in most cases, that meant that you would load a pixel color and then you would store it multiple times. Mm-hmm. So that was faster than even copying an image in a normal conventional case, because most of the time the image is expanded. So instead of doing one read, one write for a simple copy, you might be doing one read and 3 or 4 writes as it got really big. And that had the beneficial aspect of just when you needed the performance most, when things are covering the screen, it was giving you the most acceleration for that.
By the way, were you able to understand this through thinking about it, or were you testing like the right speed and like?
So this again comes back to, I can find the antecedents for things like this. So back in the Apple II days, the graphics were essentially single bits at a time. And if you wanted to make your little spaceship, if you wanted to make it smoothly go across the world, if you just took the image and you drew it out at the next location, you would move by 7 pixels at a time. So it would go chunk, chunk, chunk. If you wanted to make it move smoothly, you actually had to make 7 versions of the ship that were pre-shifted. You could write a program that would shift it dynamically, but on a 1 megahertz processor, that's not going anywhere fast. So if you wanted to do a smooth moving, fast action game, you made separate versions of each of these sprites. Now, there were a few more tricks you could pull that if it still wasn't fast enough, you could make a compiled shape where instead of this program that normally copies an image and says like, get this byte from here, store it here, get this byte, store this byte. If you've got the memory space, you could say, I'm going to write the program that does nothing but draw this shape. It's going to be like, I'm going to load the immediate value 25, which is some bit pattern, and then I'm going to store that at this location. Rather than loading something from memory that involved indexing registers and this other slow stuff, you could go ahead and say, no, I'm going to hard code the exact values of all of the image right into the program. Now, this was always a horrible trade-off there, because you didn't have much memory and you didn't have much speed. But if you had something that you wanted to go really fast, you could turn it into a program. And that was, knowing about that technique is what made me think about some of these unwinding it for the PC, where people that didn't come from that background were less likely to think about that.
I mean, there's some deep parallels probably to human cognition as well. There's something about optimizing and compressing the processing of new information that requires you to predict the possible ways in which the game or the world might unroll, and you have something like compiled scalars always there. So you have like you have a prediction of how the world will unroll, and you have some kind of optimized data structure for that prediction, and then you can modify if the world turns out to be different. You can modify in slight ways.
And as far as building out techniques, so much of the brain is about the associative context. They're just, when you learn something, it's in the context of something else, and you can have faint, tiny little hints of things. And I do think there are some deep things, around like sparse distributed memories and boosting. That's like, if you can just be slightly above the noise floor of having some hint of something, you can have things refined into pulling the memory back up. So being a programmer and having a toolbox of like all of these things that I did in all of these previous lives of programming tasks, that still matters to me about how I'm able to pull up some of these things. Like in that case, it was something I did on the Apple II, then being relevant for the PC. And I have still cases when I would work on mobile development, then be like, okay, I did something like this back in the Doom days, but now it's a different environment, but I still had that tie. I can bring it in and I can transform it into what the world needs right now. And I do think that's actually one of the very core things with human cognition and brain-like functioning, is finding these ways about, your brain is kind of everything everywhere all at once. It is just a set of all of this stuff that is just fetched back by these queries that go into it, and they can just be slightly above the noise floor with random noise in your neurons and synapses that are affecting exactly what gets pulled up.
So you're saying some of these very specific solutions for different games, you find that there's a kernel of a deep idea that's generalizable to other things.
Yeah, you can't predict what it's going to be, but that idea of, like, I called out that compiled shaders in the foreword that I wrote for that the Game Engine Black Book as, it's kind of an endpoint of unrolling code, but that's one of those things that thinking about that and having that in your mind, and I'm sure there are some programmers that, hear about that, think about it a little bit, it's kind of the mind blown moment. It's like, oh, you can just turn all of that data into code. And nowadays, you have instruction cache issues, and that's not necessarily the best idea, but there are it's an idea that has power and has probably relevance in some other areas. Maybe it's in a hardware point of view that there's a way you approach building hardware that has that same, you don't even have to think about iterating, you just bake everything all the way into it in one place.
What is the story of how you came to program Doom? What are some memorable technical challenges or innovations within that game?
So the path that we went after Wolfenstein got out, and we were on this crazy arc where Keen 1 through 3, more success than we thought. Keen 4 through 6, even more success. Wolfenstein, even more success. So we were on this this crazy trajectory for things. So actually, our first box commercial project was the Commander Keen game, but then Wolfenstein was going to have a game called Spear of Destiny, which was a commercial version, 60 new levels. So the rest of the team took the game engine pretty much as it was and started working on that. We got new monsters, but it's basically reskins of the things there. And there's a really interesting aspect about that that I didn't appreciate until much, much later, about how Wolfenstein clearly did tap out its limit about what you want to play, all the levels and a couple of our licensed things. There was a hard creative wall that you did not really benefit much by continuing to beat on it. But a game like Doom and other more modern games like Minecraft or something, there's kind of a Turing completeness level of design freedom that you get in games that Wolfenstein clearly sat on one side of. You know, all the creative people in the world could not go and do a masterpiece just with the technology that Wolfenstein had. Wolfenstein could do Wolfenstein, but you really couldn't do something crazy and different. But it didn't take that much more capability to get to Wolfenstein with the freeform lines and a little bit more artistic freedom to get to the point where people still announce new Doom levels today, all these years after, without having completely tapped out the creativity.
How did you put it? Turing complete?
Like Turing complete design space.
Design space.
Where it's like, we have the kind of computational universality on a lot of things and how different substrates work. But yeah, there's things where a box can be too small, but above a certain point, you kind of are at the point where you really have almost unbounded creative ability there.
And Doom was the first time you crossed that line.
Yeah, where there were thousands of Doom levels created, and some of them still have something new and interesting to say to the world about it.
Is that line, can you introspect what that line was? Is it in the design space? Is it something about the programming capabilities that you were able to add to the game?
So the graphics fidelity was a necessary part because the block limitations in Wolfenstein, what we had right there was not enough, the full scale blocks, although Minecraft really did show that perhaps blocks stacked in 3D and at 1/4 the scale of that, or 1/8 in volume, is then sufficient to have all of that. But the wall-sized blocks that we had in Wolfenstein was too much of a creative limitation. We licensed the technology to a few other teams. None of them made, too much of a dent with that. It just wasn't enough creative ability. But a little bit more, whether it was the variable floors and ceilings and arbitrary angles in Doom, or the smaller voxel blocks in Minecraft, is then enough to open it up to just worlds and worlds of new capabilities.
What is binary space partitioning?
So
which is one of the technologies.
Yeah. So to jump around a little bit on the story path there.
Yes.
So while the team was working on Spear of Destiny for Wolfenstein,
yes.
We had met another development team, Raven Software, while we were in Wisconsin, and they had RPG background, and I still kind of loved that, and I offered to do a game engine for them, to let them do a 3D rendered RPG instead of like most RPG games were kind of hand drawn. They made it look kind of 3D, but it was done just all with artist work rather than a real engine. And after Wolfenstein, this was still a tile-based world, but I added floors and ceilings and some lighting and the ability to have some sloped floors in different areas. And that was my intermediate step for a game called Shadowcaster. And it had slowed down enough. It was not fast enough to do our type of action things, so that they had the screen cropped down a little bit, so you couldn't go the full screen width like we would try to do in Wolfenstein. But I learned a lot. I got the floors and ceilings and lightings, and it looked great. They were great artists up there, and it was an inspiration for us to look at some of that stuff. But I had learned enough from that I had the plan I knew faster ways to do the lighting and shadowing, and I wanted to do this freeform geometry. I wanted to break out of this tile-based 90-degree world limitations. So we had, that was when we got our next stations, and we were working with these higher powered systems, and we built an editor that let us draw kind of arbitrary line segments, and I was working hard to try to make something that could render this fast enough. I was pushing myself pretty hard, and we were at a point where we could see some things that looked amazingly cool, but it wasn't really fast enough for the way I was doing it. for this flexibility. It was no longer, I couldn't just raycast into it. And I had these very complex sets of lines, and simple little worlds were okay, but the cool things that we wanted to do just weren't quite fast enough. And I wound up taking a break at that point, and I did the port. I did 2 ports of our games, Wolfenstein to the Super Nintendo. It was a crazy difficult thing to do, which was an even slower processor. It was like a couple megahertz processor, and it had been this whole thing where we had farmed out the work, and it wasn't going well, and I took it back over, and trying to make it go fast on there where it really did not have much processing power. The pixels were stretched up hugely, and it was pretty ugly when you looked at it, but in the end, it did come out fast enough to play and still be kind of fun from that. But that was where I started using BSP trees, or binary space partitioning trees. It was one of those things I had to make it faster there. It was a stepping stone where it was reasonably easy to understand in the grid world of Wolfenstein, where it was all still 90-degree angles. BSP trees I eased myself into it with that, and it was a big success. Then when I came back to working on Doom, I had this new tool in my toolbox. It was going to be a lot harder with the arbitrary angles of Doom. This was where I really started grappling with epsilon problems, and just, up until that point, I hadn't really had to deal with the fact that so many numeric things. This almost felt like a betrayal to me, where people had told me that I had mathematicians up on a bit of a pedestal, where people think I'm a math wizard, and I'm not. Everything that I did was really done with a solid high school math understanding. Algebra 2, trigonometry, and that was what got me all the way through Doom and Quake and all of that, of just understanding basics of matrices and knowing it well enough to do something with it.
What's the epsilon problems you ran into?
So when you wind up taking a sloped line and you say, I'm going to intersect it with another sloped line, then you wind up with something that's not going to be on these nice grid boundaries. With the Wolfenstein tile maps, where all you've got is horizontal and vertical lines looking at it from above, and if you cut one of them, it's just obvious the other one gets cut exactly at that point. But when you have angled lines, you're doing a kind of a slope intercept problem, and you wind up with rational numbers there, where things that are not going to evenly land on an integer or even on any fixed point value that you've got. So everything winds up having to snap to some fixed point value. So the lines slightly change their angle. You wind up, if you cut something here, this one's going to bend a little this way, and it's not going to be completely straight. And then you come down to all these questions of, well, this one is a point on an angled line. You can't answer that in finite precision unless you're doing something with actual rational numbers. And later on, I did waste far too much time chasing things like that. How do you do precise arithmetic with rational numbers? And it always blows up eventually, exponentially as you do enough.
So these kind of things are impossible with computers. So
they're possible. Again, there are paths to doing it, but you can't fit them conveniently in any of the numbers. You need to start using big nums and different factor trackings of different things.
So you have to, if you have any elements of OCD and you want to do something perfectly, you're screwed if you're working with floating point.
Yeah.
So you had to deal with this for the first time.
And there were lots of challenges there about, like, okay, they build this cool thing, and the way the BSP trees work is it basically takes the walls and it carves other walls by those walls in this clever way that you can then take all of these fragments, and then you can for sure from any given point get an ordering of everything in the world, and you can say this goes in front of this, goes in front of this, all the way back to the last thing. And that's super valuable for graphics, where kind of a classic graphics algorithm would be Painter's algorithm. You paint the furthest thing first, and then the next thing, and then the next thing, and then it comes up and it's all perfect for you. That's slow because you don't want to have drawn everything like that, but you can also flip it around and draw the closest thing to you. And then if you're clever about it, you can figure out what you need to draw that's visible beyond that.
And that's what BSP trees allow you to do.
Yeah. So it's combined with a bunch of other things, but it gives you that ordering. It's a clever way of doing things. And I remember I had learned this from one of my graphics Bible at the time, a book called Foley and Van Dam. And again, it was a different world back there. There was a small integer number of books. And this
Small
book, yeah,
number, yeah.
this book it was a big fat college textbook that I had read through many times. I didn't understand everything in it. Some of it wasn't useful to me, but they had the little thing about finite orderings of you draw a little T-shaped thing and you can say you can make a fixed ahead of time order from this, and you can generalize this with the BSP trees. And I got a little bit more information about that. And it was kind of fun later while I was working on Quake. I got to meet Bruce Naylor, who is one of the original researchers that developed those technologies, as for academic literature.
Mm-hmm.
And that was kind of fun. But I was very much just finding a tool that can help me solve what I was doing. And I was using it in this very crude way in a two-dimensional fashion rather than the general 3D. The epsilon problems got much worse in Quake in 3 dimensionals when things angle in every way. But eventually I did sort out how to do it reliably on Doom. There were still a few edge cases in Doom that were not absolutely perfect, where they even got terminologies in the communities. Like when you got to something where it was messed up, it was a Hall of Mirrors effect because you'd sweep by and it wouldn't draw something there, and you would just wind up with the leftover remnants as you flipped between the two pages. But BSP trees were important for it, but it's again worth noting that after we did Doom, our major competition came from Ken Silverman and his build engine, which was used for Duke Nukem 3D and some of the other games for 3D Realms. And he used a completely different technology, nothing to do with BSP trees. So there's not just a one true way of doing things. There were critical things about to make any of those games fast. You had to separate your drawing into, you drew vertical lines and you drew horizontal lines, just kind of changing exactly what you would draw with them. That was critical for the technologies at that time. And like all the games that were kind of like that wound up doing something similar. But there were still a bunch of other decisions that could be made. And we made good enough decisions on everything on Doom. We brought in multiplayer significantly, and it was our first game that was designed to be modified by the user community, where we had this whole setup of our WAD files and PWADs and things that people could build with tools that we released to them, and they eventually rewrote to be better than what we released. But they could build things, and you could add it to your game without destructively modifying it, which is what you had to do in all the early games. You literally hacked the data files or the executable before, while Doom was set up in this flexible way so that you could just say, run the normal game with this added on top, and it would overlay just the things that you wanted to there.
Would you say that Doom was kind of the first true 3D game that you created?
So no, it's still, Doom would usually be called a 2.5D game, where it had 3-dimensional points on it. And this is another one of these kind of pedantic things that people love to argue about what was the first 3D game. I still I'm like every month probably I hear from somebody about, well, was Doom really a 3D game or something? And I give the point where characters had 3 coordinates. So you had like an X, Y, and Z. The Cacodemon could be coming in very high and come down towards you. The walls had 3 coordinates on them. So on some sense, it's a 3D game engine, but it was not a fully general 3D game engine. You could not build a pyramid in Doom because you couldn't make a sloped wall, which was slightly different, where in that previous Shadowcaster game, I could have vertexes and have a sloped floor there, but the changes that I made for Doom to get higher speed and a different set of flexibility traded away that ability, but you literally couldn't make that. You could not, you could make different heights of passages, but you could not make a bridge over another area. You could not go over and above it. So it still had some 2D limitations to it.
That's more about the building versus the actual experience, because the experience
it felt like things would come at you, but again, you couldn't look up either.
Right.
You could only pitch. It was 4 degrees of freedom rather than 6 degrees of freedom. You did not have the ability to tilt your head this way or pitch up and down.
So that takes us to Quake. What was the leap there? What was some fascinating technical challenges? And there were a lot, or not challenges, but innovations that you've come up with.
So Quake was kind of the first thing where I did have to kind of come face to face with my limitations, where it was the first thing where I really did kind of give it my all and still come up a little bit short in terms of what and when I wanted to get it done. And the company had some serious stresses through the whole project. And we bit off a lot. So the things that we set out to do was it was going to be really a true 3D engine where it could do 6 degree of freedom. You could have all the viewpoints. You could model anything. It had a really remarkable new lighting model with the surface caching and things. That was one of those where it was starting to do some things that they weren't doing even on the very high end systems. And it was going to be completely programmable in the modding standpoint, where the thing that you couldn't do in Doom, you could replace almost all of the media, but you couldn't really change the game. There were still some people that were doing the hex editing of the executable, the dehacked things where you could change a few things about rules, and people made some early capture the flag type things by hacking the executable, but it wasn't really set out to do that. Quake was going to have its own programming language that the game was going to be implemented in it, and that would be able to be overwritten just like any of the media. Code was going to be data for that, and you would be able to have expansion packs that changed fundamental things and mods and so on. And the multiplayer was going to be playable over the internet. It was going to support client server rather than peer-to-peer. So we had the possibility of supporting larger numbers of players in disparate locations with this full flexibility of the programming overrides, with full 6 degree of freedom, modeling and viewing, and with this fancy new light mapped kind of surface caching side. It was a lot. And this was one of those things that if I could go back and tell younger me to do something differently, it would have been to split those innovations up into 2 phases in 2 separate games.
What would be phase 1 and phase 2?
So it probably would have been taking the Doom rendering engine and bringing in the TCP/IP client server,
So focusing on the multiplayer,
and the Quake C, or would have been Doom C programming language there. So I would have split that into programming language and networking with the same Doom engine, rather than forcing everybody to go towards the Quake engine, which really meant getting a Pentium. While it ran on a 486, it was not a great experience there. We could have made more people happier and gotten 2 games done in 50% more time.
So speaking of people happier, our mutual friend Joe Rogan, it seems like the most important moment of his life is centered around Quake. So it was a definitive part of his life. So would he agree with your thinking that they should split? So he, as a person who loves Quake and played Quake a lot, would he agree that you should have done the Doom engine and focus on the multiplayer for phase 1? Or in your looking back, is the 3D world that Quake created was also fundamental to the enriching experience?
I would say that what would have happened is you would have had a Doom looking but Quake feeling game 8 months earlier, and then maybe 6 months after Quake actually shipped, then there would have been the full running on a Pentium 6 degree of freedom graphics engine type things there. So it's not that it wouldn't have been there. It would have been something amazingly cool earlier, and then something even cooler somewhat later, where I would much rather have gone and done 2 one-year development efforts, cycle them through, be a little more pragmatic about that, rather than killing us ourselves on the whole Quake development. But I would say it's obviously things worked out well in the end, but looking back and saying, how would I optimize and do things differently? That did seem to be a clear case where going ahead, and we had enormous momentum on Doom. We did Doom 2 as the kind of commercial boxed version after our shareware success with the original, but we could have just made another Doom game, adding those new features in. It would have been huge. We would have learned all the same lessons, but faster, and it would have given 6 degree of freedom and Pentium class systems a little bit more time to get mainstream, because we did cut out a lot of people with the hardware requirements for Quake.
Was there any dark moments for you personally, psychologically, in having having such harsh deadlines and having to solve so many difficult technical challenges?
So I've never really had really dark black places. I mean, I can't necessarily put myself in anyone else's shoes, but I understand a lot of people have significant challenges with kind of their mental health and well-being. And I've been I've been super stressed. I've been, unhappy as a teenager in various ways, but I've never really gone to a very dark place. I just seem to be largely immune to what really wrecks people. I mean, I've had plenty of time when I'm very unhappy and miserable about something, but it's never hit me like, I believe it winds up hitting some other
Yeah.
people. I've borne up well under whatever stresses have kind of fallen on me. And I've always coped best on that when all I need to do is usually just kind of bear down on my work. I pull myself out of whatever hole I might be slipping into by actually making progress. I mean, maybe if I was in a position where I was never able to make that progress, I could have slid down further. But
Yeah.
I've always been in a place where, okay, a little bit more work. Maybe I'm in a tough spot here, but I always know if I just keep pushing, eventually I break through and I make progress. I feel good about what I'm doing. And that's been enough for me so far in my life.
Have you seen it in the distance? Like ideas of depression or contemplating suicide. Have you seen those things far?
So it was interesting when I was a teenager, I was, I was probably on some level a troubled youth. I was unhappy most of my teenage, years. I wanted to be on my own doing programming all the time. As soon as I was 18, 19, even though I was poor, I was doing exactly what I wanted and I was very happy. But high school was not a great time for me. And I had a conversation with like the school counselor and they're kind of running their script. It's like, okay, it's kind of a weird kid here. Let's carefully probe around. It's like, do you ever think about ending it all? I'm like, no, of course not. Never, not at all. This is temporary. Things are going to be better.
Wow.
And that's always been kind of the case for me. And obviously that's not that way for everyone. And other people do react differently. And
What was your escape from the troubled youth? Like music, video games, books. How did
yeah.
you escape from a world that's full of cruelty and suffering and that's absurd?
Yeah, I mean, I was not, I was not a victim of cruelty and suffering. It's like I was an unhappy, somewhat petulant youth, and in my
Yes.
point where I'm not putting myself up with anybody else's suffering, but I was unhappy objectively. And the things that I did that very much characterized my childhood were I had books, comic books, Dungeons and Dragons, arcade games, video games. Like some of my fondest childhood memories are the convenience stores, the 7-Elevens and Quick Trips, because they had a spinner rack of comic books and they had a little side room with 2 or 3 video games, arcade games in it. And that was very much my happy place. If I get my comic books and if I could go to a library and, go through the little 000 section where computer books were supposed to be. And there were a few sad little books there, but still just being able to sit down and go through that. And I read a ridiculous number of books, both fiction and nonfiction as a teenager. And my rebelling in high school was just sitting there with my nose in a book, ignoring the class through lots of it. And teachers had a range of reactions to that, some more accepting of it than others.
I'm with you on that. So let us return to Quake for a bit with the technical challenges. What everything together from the networking to the graphics. What are some things you remember that were innovations you had to come up with in order to make it all happen?
Yeah, so there were a bunch of things on Quake where, on the one hand, the idea that I built my own programming language to implement the game in. Looking back, and I try to tell people, it's like every high-level programmer sometime in their career goes through and they invent their own language. It just seems to be a thing that's pretty broadly done. People will be like, I'm going to go write a computer programming language.
Yeah.
And I don't regret having done it, but after that, I switched from Quake C, my quirky little pseudo object-oriented or entity-oriented language there. Quake 2 went back to using DLLs with C, and then Quake 3, I implemented my own C interpreter or compiler, which was a much smarter thing to do that I should have done originally for Quake. But building my own language was an experience. I learned a lot from that. And then there was a generation of game programmers that learned programming with Quake C, which I feel kind of bad about because, we give JavaScript a lot of crap, but Quake C was nothing to write home about there. But it allowed people to do magical things. You get into programming not because you love the BNF syntax of a language. It's because the language lets you do something that you cared about.
And here's very much you could do something in a whole beautiful three-dimensional world.
And the idea and the fact that the code for the game was out there, you could say, I like the shotgun, but I want it to be more badass. You go in there and say, okay, now it does 200 points damage. And then you go around with a big grin on your face, blowing up monsters all over the game. So it's, it is not what I would do today going back with that language, but that was a big part of it. Learning about the networking stuff, because it's interesting where I learned these things by reading books. So I would get a book on networking, find something, I read all about it and learn, okay, packets, they can be, out of order, lost, or duplicated. These are all the things that can theoretically happen to packets. So I wind up spending all this time thinking about how do we deal about all of that? And it turns out, of course, in the real world, those are things that, yes, theoretically can happen with multiple routes, but they really aren't things that your 99.999% of your packets have to deal with. So there was learning experiences about lots of that, and like why when TCP is appropriate versus UDP, and how if you do things in UDP, you wind up reinventing TCP badly in almost all cases. So there's good arguments for using both for different game technology, different parts of the game process, transitioning from level to level and all. But the graphics were the showcase of what Quake was all about. It was this graphics technology that nobody had seen there. And it was a while before, there were competitive things out there. And it went a long time internally really not working, where we were even building levels where the game just was not at all shippable, with large fractions of the world like disappearing, not being there, or being really slow in various parts of it. And it was this act of faith. It's like, I think I'm going to be able to fix this. I think I'm going to be able to make this work. And lots of stuff changed where the level designers would build something and then have to throw it away as something fundamental in the kind of graphics or level technology changed. And so there were two big things that contributed to making it possible at that time frame. Two new things. There was certainly hardcore optimized low-level assembly language. And this was where I had hired Michael Abrash away from Microsoft. And he had been one of my early inspirations, where that back in the soft disk days, the library of magazines that they had, some of my most treasured ones were Michael Abrash's articles in Dr. Dobbs' journal. And it was amazing. After all of our success in Doom, we were able to kind of hit him up and say, hey, we'd like you to come work at id Software. And he was in the senior technical role at Microsoft. And and he was on track and this was right when Microsoft was starting to take off. And I did eventually, convince him that what we were doing was going to be really amazing with Quake. It was going to be something nobody had seen before. It had these aspects of what we were talking about. We had metaverse talk back then. We had read Snow Crash, and we knew about this. And Michael was big into the science fiction, and we would talk about all that and kind of spin this tale. And it was some of the same conversations that we have today about the metaverse, about how you could have different areas linked together by portals, and you could have user-generated content and changing out all of these things.
So you really were creating the metaverse with Quake.
And we like talked about things like Doom used to be advertised as a virtual reality experience. That was the first wave of virtual reality was in the late 80s and early 90s. You had like the Lawnmower Man movie, and you had Time and Newsweek talking about the early VPL headsets. And of course, that cratered so hard that people didn't want to look at virtual reality for decades afterwards, where it was smoke and mirrors. It was not real in the sense that you could actually do something real and valuable with it. But still, we had that kind of common set of talking points, and we were talking about what these games could become and how you'd like to see people building all of these creative things, because we were seeing an explosion of work with Doom at that time, where people were doing amazingly cool things. Like we saw cooler levels than we had built coming out of the user community, and then people finding ways to, change the characters in different ways. And it was great. And we knew what we were doing in Quake was removing those last things. There was some quirky things with a couple of the data types that didn't work right for overriding, and then the core thing about the programming model. And I was definitely going to hit all of those in Quake. But the graphics side of it was I it was still, I knew what I wanted to do. And it was one of these hubris things where it's like, well, so far I've been able to kind of kick everything that I set out to go do. But Quake was definitely a little bit more than could be comfortably chewed at that point. But Michael was one of the strongest programmers and graphics programmers that I knew, and he was one of the people that I trusted to write assembly code, better than I could. And there's a few people that I can point to about things like this where I'm a world-class optimizer. I mean, I make things go fast, but I recognize there's a number of people that can write tighter assembly code, tighter SIMD code, or tighter CUDA code than I can write. My best strengths are a little bit more at the system level. I mean, I'm good at all of that, but the most leverage comes from making the decisions that are a little bit higher up, where you figure out how to change your large scale problems so that these lower level problems are easier to do, or it makes it possible to do them in a uniquely fast way. So most of my big wins in a lot of ways, from all the way from the early games through VR and the aerospace work that I'm doing or did, and hopefully the AI work that I'm working on now, is finding an angle on something that means you trade off something that you maybe think you need, but it turns out you don't need. And by making a sacrifice in one place, you can get big advantages in another place.
Is it clear at which level of the system those big advantages can be gained?
It's not always clear. And that's why the thing that I try to make one of my core values, and I proselytize to a lot of people, is trying to know the entire stack, trying to see through everything that happens. And it's almost impossible on like the web browser level of things, where there's so many levels to it, but you should at least understand what they all are, even if you can't understand all the performance characteristics at each level. But it goes all the way down to literally the hardware. So what is this chip capable of? And what is this software that you're writing capable of? And then with this architecture you put on top of that, then the ecosystem around it, all the people that are working on it. So there are all these decisions, and they're never made in a globally optimal way, but sometimes you can drive a thread of global optimality through it. You can't look at everything, it's too complicated, but sometimes you can step back up and make a different decision. And we kind of went through this on the graphics side on Quake, where in some ways it was kind of bad, where Michael would spend his time writing, like I'd rough out the basic routines, like, okay, here's our span rasterizer. And he would spend a month writing this, beautiful cycle optimized piece of assembly language that does what I asked it to do. And he did it faster than like my original code would do, or probably what I would be able to do even if I had spent that month on it. But then we'd have some cases when I'd be like, okay, well, I figured out at this higher level, instead of drawing these in a painter's order here, I do a span buffer and it cuts out 30% or 40% of all of these pixels, but it means you need to rewrite kind of this interface of all of that. And I could tell that wore on him a little bit, but in the end, it was the right thing to do, where we wound up changing that rasterization approach, and we wound up with a super optimized assembly language core loop, and then a good system around it, which minimized how much that had to be called.
And so in order to be able to do this kind of system level thinking, whether we're talking about game development, aerospace, nuclear energy, AI, VR, you have to be able to understand the hardware, the low level software, the high level software, the design decisions, the whole thing, the full stack of it.
Yeah. And that's where a lot of these things become possible. When you're bringing the future forward, I mean, there's a pace that everything just kind of glides towards, where we have a lot of progress that's happening at so many different ways. You kind of slide towards progress just left to your own. Programs just get faster. For a while, it wasn't clear if they were going to get fatter quicker than they get faster, and it cancels out. But it is clear now in retrospect. No, programs just get faster and have gotten faster for a long time. But if you want to do something like back at that original talking about scrolling games, say, well, this needs to be 5 times faster. Well, we can wait 6 years and it'll naturally get that much faster at that time. Or you come up with some really clever way of doing it. So there are those opportunities like that in a whole bunch of different areas. Now, most programmers don't need to be thinking about that. There's not that many there's a lot of opportunities for this, but it's not everyone's workaday type stuff. So everyone doesn't have to know how all these things work. They don't have to know how their compiler works, how, the processor chip manages cache eviction and all these low level things. But sometimes there are powerful opportunities that you can look at and say, we can bring the future 5 years faster. We can do something that, wouldn't it be great if we could do this? Well, we can do it today if we make a certain set of decisions. And it is, in some ways, smoke and mirrors, where you say it's like Doom was a lot of smoke and mirrors, where people thought it was more capable than it actually was, but we picked the right smoke and mirrors to deploy in the game, where by doing this, people will think that it's more general. We're going to amaze them with what they've got here, and they won't notice that it doesn't do these other things. So smart decision making at that point, that's where that kind of global, holistic, top-down view can work. And I'm really a strong believer that technology should be sitting at that table having those discussions, because you do have cases where you say, well, you want to be the Jonathan Ivey or whatever, where it's a pure design solution. And that's in some cases now where you truly have almost infinite resources. Like if you're trying to do a scrolling game on the PC now, you don't even have to talk to a technology person. You can just have, any intern can make that go run as fast as it needs to there, and it can be completely design based. But if you're trying to do something that's hard, either that can't be done for resources like VR on a mobile chipset, or that we don't even know how to do yet, like artificial general intelligence, it's probably going to be a matter of coming at it from an angle. Like, for AGI, we have some of the Hutter principles about how you can, AXI or there are theoretical ways that you can say this is the optimal learning algorithm that can solve everything, but it's completely impractical. You just can't do that. So clearly you have to make some concessions for general intelligence, and nobody knows what the right ones are yet. So people are taking different angles of attack. I hope I've got something clever to come up with in that space.
It's been surprising to me, and I think perhaps it is a principle of progress, that smoke and mirrors somehow is the way you build the future. You kind of fake it till you make it, and you almost always make it. And I think that's going to be the way we achieve AGI. That's going to be the way we build consciousness into our machines. There's philosophers debate about the Turing test is essentially about faking it till you make it. You start by faking it, and I think that always leads to making it. Because if we look at history,
arguments, as soon as people start talking about qualia and consciousness and Chinese rooms and things, it's like, I just check out. I just don't think there's any value in those conversations. It's just like, go ahead, tell me it's not going to work. I'm going to do my best to try to make it work anyways.
I don't know if you work with legged robots. There's a bunch of these. They sure as heck make me feel like they're conscious in a certain way that's not here today, but is you could see the kernel.
Yeah.
It's like the flame, the beginnings of a flame.
We don't have line of sight, but there's glimmerings of light in the distance for all of these things.
Yeah, I'm hearing murmuring in a distant room. Well, let me ask you a human question here. You've in the game design space, you've done a lot of incredible work throughout, but in terms of game design, you have changed the world, and there's a few people around you that did the same. So famously, there's some animosity, there's much love, but there's some animosity between you and John Romero. What is at the core of that animosity and human tension? And
so there really hasn't been for a long time. And even at the beginning, it's like, yes, I did push Romero out of the company. And this is one of the things that I look back, if I could go back telling my younger self some advice about things, the original founding kind of corporate structure of id Software really led to a bunch of problems. We started off with us as equal partners, and we had a buy-sell agreement because we didn't want outsiders to be telling us what to do inside the company. And that did lead to a bunch of the problems where I was sitting here going, it's like, all right, I'm working harder than anyone. I'm doing these technologies, nobody's done before, but we're all equal partners. And then I see, somebody that's not working as hard, and and I mean, I can't say I was the most mature about that. I was, 20 something years old, and it did bother me when I'm like, everybody, okay, we need to all pull together, and we've done it before. Everybody, we know we can do this if we get together and we grind it all out. But not everybody wanted to do that for all time, and I was the youngest one of the crowd there. I had different sets of kind of backgrounds and motivations, and left at that point where it was, all right, either everybody has to be contributing like up to this level or they need to get pushed out, was not, that was not a great situation. And I look back on it and no, we pushed people out of the company that could have contributed if there was a different framework for them. And the modern kind of Silicon Valley, like let your stock vest over a time period and maybe it's non-voting stock and all those different things. We knew nothing about any of that. I mean, we didn't know what we were doing in terms of corporate structure or anything.
So if you think the framework was different, some of the human tension could have been a little bit alleviated.
It almost certainly would have. I mean, I look back at that and it's like even trying to sum it up in my mind, it's like I know I was really, really angry about like Romero not working as hard as I wanted him to work or not carrying his load on the design for Quake and coming up with things there. But he was definitely doing things. He made some of the best levels there. He was working with some of our external teams like Raven on the licensing side of things. But but there were differences of opinion about it. But he landed, right on his feet. He got $20 million from IDOS to go do Ion Storm, and he got to do things his way and spun up 3 teams simultaneously, because that was always one of the challenging things in id, where we were doing these single string, one project after another. And I think some of them, wanted to grow the company more. And I didn't, because I knew people that were saying that, oh, companies turn to shit when you got 50 employees. It's just a different world there. And I loved our little dozen people working on the projects. But you can look at it and say, well, business realities matter. It's like you're super successful here and we could take a swing and a miss on something, but you do it a couple times and you're out of luck. There's a reason companies try to have multiple teams running at one time. And so that was, again, something I didn't really appreciate back then.
So if you look past all that, you did create some amazing things together. What did you love about John Romero? What did you respect and appreciate about him? What did you admire about him? What did you learn from him?
When I met him, he was the coolest programmer I had ever met. He had done all of this stuff. He had made all of these games. He had worked at, one of the companies that I thought was the coolest, at Origin Systems. And he knew all this stuff. He made things happen fast. And he was also kind of a polymath about this, where he drew his own art. He made his own levels, as well as, he worked on sound design systems on top of actually being a really good programmer. And we went through it was kind of fun, where one of the early things that we did, where there was kind of the young buck bit going in, where I was the new guy and he was the top man programmer at the soft disk area. And eventually we had sort of a challenge over the weekend that we were going to race to implement this game, to port one of our PC games back down to the Apple II. And that was where we finally kind of became clear. It's like, okay, Carmack stands a little bit apart on the programming side of things. And, but Romero then very gracefully moved into, well, he'll work on the tools, he'll work on the systems, do some of the game design stuff, as well as contributing on, starting to lead the design aspects of a lot of things. So he was, enormously valuable in the early stuff. And so much of Doom and even Quake have his stamp on it in a lot of ways. But he wasn't at the same level of focus that I brought to the work that we were doing there. And he really did. We hit such a degree of success that it was all in the press about that. The Rockstar game programmers.
Yeah. It's the Beatles problem.
Yeah. He ate it up, and he did personify. There was the whole game developers with Ferraris that we had there. And I thought that, that led to some challenges there. But so much of the stuff that was great in the games did come from him, and I would certainly not take that away from him. And even after we parted ways and he took his swing with IDOS, in some ways he was ahead of the curve with mobile gaming as well, where one of his companies after IDOS was working on feature phone game development. And I wound up doing some of that just before the iPhone, crossing over into the iPhone phase there. And that was something that clearly did turn out to be a huge thing, although he was too early for what he was working on at that time. We've had pretty cordial relationships where I was happy to talk with him anytime I'd run into him at a conference. I have actually had some other people just say it's like, oh, you shouldn't go over there and give him the time of day, or felt that Masters of Doom was played things up in a way that I shouldn't be too happy with, but I'm okay with all of that. And
So you
I
still
know,
got love in your heart.
yeah, I mean, I just talked with him like last year, or I guess it was even this year, about mentioning that I'm going off doing this AI stuff. I'm going big into artificial intelligence, and he had a bunch of ideas for how AI is going to play into gaming, and asked if I was interested in collaborating. And it's not in line with what I'm doing, but I do. I wish almost everyone the best. I mean, I know I may not have parted on the best of terms with with some people, but I was thrilled to see Tom Hall writing VR games now. He wrote working on a game called Demio, which is really an awesome VR game. It's like Dungeons and Dragons. We all used to play Dungeons and Dragons together. That was one of the things. That was what we did on Sundays in the early id days. I would dungeon master and they'd all play. And so it really made me smile seeing Tom involved with an RPG game in virtual reality.
You were the CTO of Oculus VR since 2013, and maybe lessen your involvement a bit in 2019. Oculus was acquired by Facebook, now Meta, in 2014. You've spoken brilliantly about both the low-level details, the experimental design, and the big picture vision of virtual reality. Let me ask you about the metaverse, the big question here, both philosophically and technically. How hard is it to build the metaverse? What is the metaverse, in your view? You started with discussing and thinking about Quake as a kind of a metaverse. As you think about it today, what is the metaverse? The thing that could create this compelling user value, this experience that will change the world, and how hard is it to build it?
So the term comes from Neil Stephenson's book Snow Crash, which many of us had read back in the 90s. It was one of those kind of formative books. And there was this sense that the possibilities and kind of the freedom and unlimited capabilities to build a virtual world that does whatever you want, whatever you ask of it, has been a powerful draw for generations of developers, game developers specifically, and people that are thinking about more general purpose applications. So we were talking about that back in the Doom and Quake days, about how do you wind up with an interconnected set of worlds that you kind of visit from one to another. And as web pages were becoming a thing, you start thinking about what is the interactive kind of 3D based equivalent of this. And there were a lot of really bad takes. You had Vermal, then virtual reality markup languages, and there's aspects like that came from people saying, well, what kind of capabilities should we develop to enable this? Mm-hmm. And that kind of capability first work has usually not panned out very well. On the other hand, we have successful games that started with things like Doom and Quake and communities that formed around those, and whether it was server lists in the early days or literal portaling between different games. And then modern things that are on completely different order of magnitude, like Minecraft and Fortnite, that have 100 million plus users. Mm. I still think that that's the right way to go to build the metaverse. Is you build something that's amazing that people love and people wind up spending all their time in because it's awesome, and you expand the capabilities of that.
So now, even if it's a very basic experience,
as long as people,
awesome,
Minecraft is an amazing case study in so many things. Where what's been able to be done with that is really enlightening. And there are other cases where, like right now, Roblox is basically a game construction kit aimed at kids, and that was a capability first play, and it's achieving scale that's on the same order of those things. So it's not impossible, but my preferred bet would be you make something amazing that people love and you make it better and better. And that's where I could say we could have gone back and followed a path kind of like that in the early days. If you just kind of take the same game, whether it's when Activision demonstrated that you could make Call of Duty every year, and not only is it not bad, people kind of love it, and it's very profitable. The idea that you could have taken something like that, take a great game, release a new version every year that lets the capabilities grow and expand, to start saying it's like, okay, it's a game about running around and shooting things, but now you can have bring your media into it. You can add persistence of social signs of life, or whatever you want to add to it. I still think that's quite a good position to take, and I think that while Meta is doing a bottoms up capability approach with Horizon Worlds, where it's a fairly general purpose, creators can build whatever they want in their sort of thing. I am, it's hard to compare and compete with something like Fortnite, which also has enormous amounts of creativity, even though it was not designed originally as a general purpose sort of thing. So we have examples on both sides. Me personally, I would have bet on trying to do entertainment, valuable destination first, and expanding from there.
So can you imagine the thing that will be kind of, if we look back a couple of centuries from now and you think about the experiences that marked the singularity, the transition in where most of our world moved into virtual reality, what do you think those experiences will look like?
So I do think it's going to be kind of like the way the web slowly took over, where you're the frog in the pot of water that's slowly heating up, where having lived through all of that, I remember when it was shocking to start seeing the first website address on a billboard, when you're like, hey, my computer world is infecting the real world. This is spreading out in some way, but there's still, when you look back and say, well, what made the web take off? And it wasn't a big bang sort of moment there. It was a bunch of little things that turned out not to even be the things that are relevant now that brought them into it. So
Well, I wonder if like you said, you're not a historian. So maybe there's a historian out there that could really identify that moment, data-driven way. It could be like MySpace or something like that. Maybe the first major social network that really reached into non-geek world or something like that.
I think that's kind of the fallacy of historians, though, looking for some of those kind of primary dominant causes, where so many of these things are like, we see an exponential curve, but it's not because like one thing is going exponential. It's because we have hundreds of little sigmoid curves overlapped on top of each other, and they just happen to keep adding up so that you've got something kind of going exponential at any given point. But no single one of them was the critical thing. There were, dozens and dozens of things. I mean, seeing the transitions of stuff, like, as obviously MySpace giving way to other things, but even like blogging giving way to social media, and getting resurrected in other guises, and
the memes
things
with
that
the
happened there.
dancing baby gif, or whatever, the all your base now belong to us, whatever those early memes that led to the modern memes, and the humor on the different evolution of humor on the internet that I'm sure the historians will also write books about, from the different websites that create the infrastructure for that humor, like Reddit and all that kind of stuff.
So people will go back and they will name firsts and critical moments,
Yeah.
but it's probably going to be a poor approximation of what actually happens. And we've already seen, like in the VR space, where it didn't play out the way we thought it would in terms of what was going to be like the modern era of VR basically started with my E3 demo of Doom 3 on the Rift prototype. So we're like, first person shooters in VR, match made in heaven, right?
Mhm.
And that didn't work out that way at all. They have the most comfort problems with it. And then the most popular virtual reality app is Beat Saber, which nobody predicted back then.
What's that make you, from first principles, if you were to like reverse engineer that? Why are these like silly fun games
Well,
the most?
it actually makes very clear sense when you analyze it from hindsight and look at the engineering reasons, where it's not just that it was a magical, quirky idea. It was something that played almost perfectly to what turned out to be the real strengths of VR, where The one thing that I really underestimated importance in VR was the importance of the controllers. I was still thinking we could do a lot more with a gamepad, and just the amazingness of taking any existing game, being able to move your head around and look around. That was really amazing. But the controllers were super important. But the problem is, so many things that you do with the controllers just suck. It feels like it breaks the illusion, like trying to pick up glasses with the controllers where you're like, oh, use the grip button when you're kind of close and it'll snap into your hand. All of those things are unnatural actions that you do them and it's still part of the VR experience. But Beat Saber winds up playing only to the strengths. It completely hides all the weaknesses of it because you are holding something in your hand. You keep a solid grip on it the whole time. It slices through things without ever bumping into things. You never get into the point where, I'm knocking on this table, but in VR, my hand just goes right through it. So you've got something that slices through. So it's never your brain telling you, oh, I should have hit something. You've got a lightsaber here. It's just you expect it to slice through everything. Audio and music turned out to be a really powerful aspect of virtual reality where you're blocking the world off and constructing the world around you. And being something that can run efficiently on even this relatively low-powered hardware and can have a valuable loop in a small amount of time, where a lot of modern games, you're supposed to sit down and play it for an hour just to get anywhere. Sometimes a new game takes an hour to get through the tutorial level. And that's not good for VR for a couple reasons. You do still have the comfort issues if you're moving around at all, but you've also got just discomfort from the headset, battery lifespan on the mobile versions. So having things that do break down into 3 and 4 minute windows of play, that turns out to be very valuable from a gameplay standpoint. So it winds up being kind of a perfect storm of all of these things that are really good. It doesn't have any of the comfort problems. You're not navigating around. You're standing still. All the stuff flies at you. It has plays to audio strengths. It adds the whole fitness in VR. Nobody was thinking about that back at the beginning. And it turns out that is an excellent daily fitness thing to be doing. If you go play an hour of Beat Saber or Supernatural or something, that is legit solid exercise. And it's more fun than doing it just about any other way there.
So that's kind of the arcade stage of things. If I were to say, with my experience with VR, the thing that I think is powerful is maybe it's not here yet, but the degree to which it is immersive in the way that Quake is immersive. It takes you to another world. For me, because I'm a fan of role-playing games, the Elder Scrolls series, like Skyrim or even Daggerfall, it just takes you to another world. And when you're not in that world, you miss not being there. And then you kind of want to stay there forever because life is shitty.
Well, the whole point,
and you just want to go to
VR
this place.
Is that there was a time when we were kind of asked to come up with like, what's your view about VR? And my pitch was that it should be better inside the headset than outside. It's the world as you want it.
Yeah.
And everybody thought that was dystopian. And like, that's like, oh, you're just going to forget about the world outside. And I don't get that mindset where the idea that if you can make the world better inside the headset than outside, you've just improved the person's life that has a headset that can wear it. And there are plenty of things that we just can't do for everyone in the real world. Everybody can't have Richard Branson's private island, but everyone can have a private VR island, and it can have the things that they want on it. And there's a lot of these kind of rivalrous goods in the real world that VR can just be better at. We can do a lot of things like that can be very, very rich. So yeah, I think it's going to be a positive thing, this world where people want to go back into their headset, where it can be better than somebody that's living in a tiny apartment can have a palatial estate in virtual reality. They can have all their friends from all over the world come over and visit them without everybody getting on a plane and meeting in some place and dealing with all the other logistics hassles. There is real value in the presence that you can get for remote meetings. It's all the little things that we need to sort out, but those are things that we have line of sight on. People, that have been in like a good VR meeting using workrooms where you can say, oh, that was better than a Zoom meeting. But of course, it's more of a hassle to get into it. Not everyone has the headset. Interoperability is worse. You cap out at a certain number. There's all these things that need to be fixed, but that's one of those things you can look at and say, we know there's value there. We just need to really grind hard to file off all the rough edges and make that possible.
So you do think we have line of sight, because there's a reason, like I do this podcast in person, for example. Doing it remotely, it's not the same. And if somebody were to ask me why it's not the same, I wouldn't be able to write down exactly why. But you're saying that it's possible, whatever the magic is for in-person interaction, that immersiveness of the experience, we are almost there.
Yes.
So it's
so
a
the
technical
idea of
problem.
like, I'm doing a VR interview with someone. I'm not saying it's here right now, but you can see glimmers of what it should be. And we largely know what would need to be fixed and improved to, like you say, there's a difference between a remote interview doing a podcast over Zoom or something and face-to-face. There's that sense of presence, that immediacy, the super low latency responsiveness, being able to see all the subtle things there, just occupying the same field of view. And all of those are things that we absolutely can do in VR. And that simple case of a small meeting with a couple people, that's the much easier case than everybody thinks the Ready Player One multiverse with 1,000 people going across a huge bridge to amazing places. That's harder in a lot of other technical ways. Not to say we can't also do that, but that's further away and has more challenges. But this small thing about being able to have a meeting with one or a few people and have it feel real, feel like you're there, like you have the same interactions and talking with them. You get subtle cues as we start getting eye and face tracking and some of the other things on high-end headsets. A lot of that is going to come over, and it doesn't have to be as good. This is an important thing that people miss, where there was a lot of people that, especially rich people, that would look at VR and say, it's like, oh, this just isn't that good. And I'd say it's like, well, you've already been courtside, backstage, and on pit row, and you've done all of these experiences because you get to do them in real life. But most people don't get to. And even if the experience is only half as good, if it's something that they never would have gotten to do before, it's still a very good thing. And as we can push that number up over time. It has a minimum viable value level when it does something that is valuable enough to people, as long as it's better inside the headset on any metric than it is outside, and people choose to go there, we're on the right path. And we have a value gradient that I'm just always hammering on. We can just follow this value gradient, just keep making things better rather than going for that one close your eyes, swing for the fences, kind of silver bullet approach.
Well, I wonder if there's a value gradient for in-person meetings, because if you get that right, I mean, that would change the world.
Yeah.
That it doesn't need to, I mean, you don't need Ready Player One. But I wonder if there's that value gradient you can follow along, because if there is and you follow it, then there'll be a certain like phase shift at a certain point where people will shift from Zoom to this. I wonder what are the bottlenecks? Is it software? Is it hardware? Is it all about latency?
So I have big arguments internally about strategic things like that, where like the next headset that's coming out that we've made various announcements about is going to be a higher end headset, more expensive, more features. Lots of people want to make those trade-offs. We'll see what the market has to say about the exact trade-offs we've made here. But if you want to replace Zoom, you need to have something that everybody has. And
so you like cheaper.
I like cheaper because also lighter and cheaper wind up being a virtuous cycle there, where expensive and more features tends to also lead towards heavier, and it just kind of goes, it's like, let's add more features. The features are not, they have physical presence and weight and draw from batteries and all of those things. So I've always favored a lower end, cheaper, faster approach. That's why I was always behind the mobile side of VR rather than the higher end PC headsets. And I think that's proven out well. But ideally we have a whole range of things, but if you've only got one or two things, it's important that those two things cover the scope that you think is most important. When we're in a world when it's like cell phones and there's 50 of them on the market covering every conceivable ecological niche you want, that's going to be great, but we're not going to be there for a while.
Where are the bottlenecks? Is it the hardware or the software?
Yeah. So right now, you can get workrooms on Quest, and you can set up these things, and it's a pretty good experience. It's surprisingly good.
So I haven't tried it.
Yeah.
It's surprisingly good.
The voice latency is better on that than a lot better than a Zoom meeting. So you've got a better sense of immediacy there. The expressions that you get from the current hardware with just kind of your controllers and your head is pretty realistic feeling. And you got a pretty good sense of being there with someone with it.
Are these like avatars of people?
Yeah.
Like do you get to see their body?
Yeah.
And they're sitting around a table?
Yeah.
And it feels better than Zoom?
Better than you'd expect for that. It is definitely, I'd say it's quite a bit better than Zoom when everything's working right, but there's still all the rough edges of the reason Zoom became so successful is because they just nailed the usability of everything. Mm-hmm. It's high quality with a absolutely first-rate experience. And we are not there yet with any of the VR stuff. I'm trying to push hard to get, I keep talking about it's like it needs to just be one click to make everything happen. Yeah. And we're getting there in our home environment, not the whole Workrooms application, but the main home where you can now kind of go over and click an invite, and it still winds up taking 5 times longer than it should, but we're getting close to that where you click there, they click on their button, and then they're sitting there in this good presence with you. But latencies need to get a lot better. User interface needs to get a lot better. Ubiquity of the headsets needs to get better. We need to have 100 million of them out there just so that everybody knows somebody that uses this all the time.
Well, I think it's a virtuous cycle because I do think the interface is the thing that makes or breaks this kind of revolution. It's so interesting how like you said one click, but it's also like how you achieve that one click. I don't know. What is can I ask a dark question? Maybe let's keep it outside of Meta. But this is about Meta, but also Google and big company. Are they able to do this kind of thing? It seems like, let me put on my cranky old man hat, is they seem to not do a good job of creating these user-friendly interfaces as they get bigger and bigger as a company. Like Google has created some of the greatest interfaces ever early on, and creating Gmail, just so many brilliant interfaces, and it just seems to be getting crappier and crappier at that. Same with Meta, same with Microsoft. It seems to get worse and worse at that. I don't know what it is. Because they've become more conservative, careful, risk averse. Is that why? Can you speak to that?
It's been really eye-opening to me working inside a tech titan where I had my small companies, and then we're acquired by a mid-sized game publisher, and then Oculus getting acquired by Meta, and Meta has grown by a factor of many just in the 8 years since the acquisition. So I did not have experience with this, and it was interesting because I remember like previously my benchmark for kind of use of resources was some of the government programs I interacted with on the aerospace side. And I remember thinking there's an Air Force program and they spent $50 million and they didn't launch anything. They didn't even build anything. It was just kind of like they made a bunch of papers and had some parts in a warehouse and nothing came of it. It's like $50 million. And I've had to radically recalibrate my sense of like how much money can be spent without
a product at the end
resources. Where on the plus side, VR has turned out we've built pretty much exactly what we just passed the 10-year mark then from my first demo of the Rift. And if I could have said what I wanted to have, it would have been a standalone inside-out tracked 4K resolution headset that could still plug into a PC for high-end rendering. And that's exactly what we've got on Quest 2 right now.
First of all, let's pause on that with me being cranky and everything. It's what Meta achieved with Oculus and so on is incredible. I mean, when I thought about the future of VR, this is what I imagined in terms of hardware, I would say. and maybe in terms of the experience as well, but it's still not there somehow.
On the one hand, we did kind of achieve it and win, and we've sold, we're a success right now. But the amount of resources that have gone into it, it winds up getting cluttered up in accounting where Mark did announce that they spent $10 billion a year, like on Reality Labs. Now, Reality Labs covers a lot. VR was not the large part of it. It also had Portal and Spark and the big AR research efforts. And it's been expanding out to include AI and other things there where there's a lot going on there. But $10 billion was just a number that I had trouble processing. I feel sick to my stomach thinking about that much money being spent. But that's how they demonstrate commitment to this, where it's not more so than Google goes and cancels all of these projects, different things like that, while Meta is really sticking with the funding of VR and AR is still further out with it. So there's something to be said for that. It's not just going to vanish. The work's going in. I just wish all those resources could be applied more effectively, because I see all these cases. I point out these examples of how a third party that we're kind of competing with in various ways. There's a number of these examples, and they do work with a tenth of the people that we do internally. And a lot of it comes from, there's the small company can just go do it, while in a big company, you do have to worry about, is there some SDK internally that you should be using because another team's making it? You have to have your cross-functional group meetups for different things. You do have more concerns about privacy or diversity and equity and safety of different things, parental issues, and things that a small startup company can just kind of, cowboy off and do something interesting. And there's a lot more that is a problem that you have to pay attention to in the big companies, but I'm not willing to believe that we are within even a factor of 2 or 4 of what the efficiency could be. I am constantly kind of crying out for, it's like, we can do better than this.
Yeah, and you wonder what the mechanisms to unlock that efficiency are. There is some sense in a large company that like an individual engineer might not believe that they can change the world. Maybe you delegate a little bit of the responsibility to be the one who changes the world in a big company, I think. But the reality is, like, the world will get changed by a single engineer anyway. So whether inside Google or inside a startup, it doesn't matter. It's just like Google and Meta needs to help those engineers believe they're the ones that are going to decrease that latency. It'll take one John Carmack, like the 20-year-old Carmack that's inside Meta right now, to change everything.
And I try to point that out and push people. It's like, try to go ahead. And when you see because you get the silo mentality where you're like, okay, I know something's not right over there, but I'm staying in my lane here. And there's a couple people that I can think about that are willing to just like hop all over the place. And man, I treasure them. The people that are just they're fearless. They will go over and they will go rebuild the kernel and change this distribution and go in and hack the firmware over here to get something done right. And that is relatively rare. There's thousands of developers and you've got a small handful that are willing to operate at that level. And and it's potentially risky for them. The politics are real in a lot of that. And I'm in the very much the privileged position of I'm more or less untouchable there, where I've been dinged like twice for, it's like, you said something insensitive in that post and you should probably not say that. But for the most part, yes, I get away with, every week I'm posting something, pretty loud and opinionated internally. And I think that's useful for the company, but it's rare to have a position like that, and I can't necessarily offer advice for how someone can do that.
Well, you could offer advice to a company in general to give a little bit of freedom for the young, the wildest ideas come from the young minds. And so you need to give the young minds freedom to think big and wild and crazy. And for that, they have to be opinionated. They have to be, they have to think crazy ideas and thoughts and pursue them with a full passion without being slowed down by bureaucracy or managers and all that kind of stuff. Obviously, startups really empower that,
Yeah.
but big companies could too. And that's a design challenge for big companies to see how can you enable that? How can you
Yeah, because
empower
the big
that?
company, there are so many resources there,
Right.
and they do, amazing things do get accomplished, but there's so much more that could come out of that. And I'm always hopeful. I'm an optimist in almost everything. I think things can get better. I think that they can improve things, that you go through a path and you're learning kind of what does and doesn't work. And I'm not ready to be fatalistic about the kind of the outcome of any of that.
Me neither. I know too many good people inside of those large companies that are incredible. You have a friendship with Elon Musk. Often when I talk to him, he'll bring up how incredible of an engineer and just a big picture thinker you are. He has a huge amount of respect for you. I just, I've never been a fly in the wall between the discussion between the two of you. I just wonder, is there something you guys debate, argue about, discuss? Is there some interesting problems that the two of you think about? You come from different worlds. Maybe there's some intersection in aerospace. Maybe there's some intersection in your new efforts in artificial intelligence in terms of thinking. Is there something interesting you could say about sort of the debates the two of you have?
So I think in some ways we do have a kind of similar background where we're almost exactly the same age, and we had kind of similar programming backgrounds on the personal computers, and even some of the books that we would read and things that would kind of turn us into the people that we are today. And I think there is a degree of sensibility similarities where we kind of call bullshit on the same things and kind of see the same opportunities in different technology. And there's that sense of, I always talk about the speed of light solutions for things, and he's thinking about kind of minimum manufacturing and engineering and operational standpoints for things. And so, I mean, I first met Elon right at the start of the aerospace era, where I wasn't familiar with, I was still in my game dev bubble. I really wasn't familiar with all the startups that were going and being successful and what went on with PayPal and all of his different companies. But, I met him as I was starting to do Armadillo Aerospace. And, he came down with kind of his right hand propulsion guy, and we talked about rockets. What can we do with this? And it was kind of specific things about like how are our flight computers set up? What are different propellant options? What can happen with different ways of putting things together? And then in some ways, he was certainly the biggest player in the sort of alt space community that was going on in the early 2000s. He was the most well funded, although his funding in the larger scheme of things compared to a NASA or something like that was really tiny. It was a lot more than I had at the time. But it was interesting. I had a point years later when I realized, okay, my financial resources at this point are basically what Elon's was when he went all in on SpaceX and Tesla. And I think in many corners he does not get the respect that he should about being a wealthy person that could just retire. And he went all in, where he was really going to, he could have gone bust. And there's plenty of people. You look at the sad athletes or entertainers that had all the money in the world and blew it. He could have been the business case example of that. But the things that he was doing, space exploration, electrification of transportation, solar city type things, these are big world level things. And I have a great deal of admiration that he was willing to throw himself so completely into that, because in contrast with myself, I was doing Armadillo Aerospace with this tightly bounded, it was John's crazy money at the time that had a finite limit on it. It was never going to impact me or my family if it completely failed. And I was still hedging my bets working at id Software at the time when he had been, really all in there. And I have a huge amount of respect for that. And people do not. The other thing I get irritated with is people that say it's like, oh, Elon's just a business guy. He just got he was gifted the money and he's just kind of investing in all of this, when he was really deeply involved in a lot of the decisions. not all of them were perfect, but he cared very much about engine material selection, propellant selection, and for years he'd be kind of telling me it's like get off that hydrogen peroxide stuff. It's like
Yeah.
liquid oxygen is the only proper oxidizer for this, and and like the times that I've gone through the factories with him, we're talking very detailed things about like how this weld is made, how this subassembly goes together, what are like startup shutdown behaviors of the different things. So he is, really in there at a very detailed level. And I think that he is the best modern example now of someone that can effectively micromanage some decisions on things on both Tesla, and SpaceX to some degree, where he cares enough about it. I worry a lot that he's stretched too thin, that you get Boring Company and Neuralink and Twitter and all of the other possible things there, where I know I've got limits on how much I can pay attention to, that I have to kind of box off different amounts of time. And I look back at my aerospace side of things. It's like I did not go all in on that. I did not commit myself at a level that it would have taken to be successful there. And and it's kind of a weird thing, just like having a discussion with him. He's the richest man in the world right now, but
Right.
he operates on on a level that is still very much in my wheelhouse on a technical side of things. So
Doing that systems level type of thinking where you
yeah.
can go to the low level details and go up high to the big picture. Do you think in aerospace arena in the next 5-10 years, do you think we're going to put a human on Mars? Like, what do you think is the interesting
No, I do. In fact,
point?
I made a bet with someone, with
Yes.
a group of people, kind of this about whether boots on Mars by 2030.
Hmm.
And this was kind of a fun story because I was at an Intel sponsored event and we had a bunch of just world class, brilliant people. And we were talking about computing stuff, but the after dinner conversation was like, what are some other things? How are they going to go in the future? And one of the ones tossed up on the whiteboard was like boots on Mars by 2030. And most of the people in the room thought, yes, they thought that like SpaceX is kicking ass. We've got all this possible stuff. Seems likely that it's going to go that way. And I said, no, I think less than 50% chance that it's going to make it there. And people, were kind of like, oh, why the pessimism or whatever. And of course, I'm an optimist at almost everything. But for me to be the one kind of outlier saying, no, I don't think so. Then I started saying some of the things. I said, well, let's be concrete about it. Let's bet $10,000 that it's not going to happen. And this was really a startling thing to see, that again, room full of brilliant people. But as soon as like money came on the line and they were like, do I want to put $10,000? And I was not the richest person in the room. There were people much better off than I
Yeah.
was. There's a spectrum, but as soon as they started thinking, it's like, oh, I could lose money by keeping my position right now. And all these engineers, they engaged their brain. They started thinking, it's like, okay, launch windows, launch delays, like how many times would it take to get this right? What historical precedents do we have? And then it mostly came down to, it's like, well, what about in transit by 2030? And then what about different things, or would you go for 2032? But one of the people did go ahead and was optimistic enough to make a bet with me. So I have a $10,000 bet that by 2030, I think it's going to happen shortly thereafter. I think there will probably be infrastructure on Mars by 2030, but I don't think that we'll have humans on Mars on 2030. I think it's possible, but I think it's less than a 50% chance. So I felt safe making that bet.
Well, I think you had an interesting point. Correct me if I'm wrong. That's a dark one. That should perhaps help people appreciate Elon Musk, which is, in this particular effort, Elon is critical to the success. SpaceX seems to be critical to humans on Mars by 2030 or thereabouts. So if something happens to Elon, then all of this collapses.
Right. And this is in contrast to the other $10,000 bet I made kind of recently, and that was self-driving cars at like a level 5 running around cities. And people have kind of nitpicked that we probably don't mean exactly level 5, but the guy I'm having the bet with is we know what we mean about this.
Jeff Atwood.
Yeah, coding horror and
Coding
Stack
horror.
Overflow and all.
Yeah. Yeah.
But yeah, I mean, it's just, he doesn't think that people are going to be riding around in robo-taxis in 2030 in major cities, just like you take an Uber now. And I think it will.
You think it will.
And the difference is everybody looks at this, it's like, oh, but Tesla's been wrong for years. They've been promising it for years and it's not here yet. And the reason this is different than the bet with Mars is Mars really is more than is comfortable a bet on Elon Musk. That is his thing, and he is really going to move heaven and earth to try to make that happen.
And perhaps not even SpaceX.
Yeah.
Perhaps just Elon Musk.
Yeah, because if Elon went away and SpaceX went public and got a board of directors, there are more profitable things they could be doing than focusing on human presence on Mars. So this really is a sort of personal thing there. And in contrast with that, self-driving cars have a dozen credible companies working really hard. And while, yes, it's going slower than most people thought it would, betting against that is a bet against almost the entire world in terms of all of these companies that have all of these incentives. It's not just, one guy's passion project. And I do think that it is solvable, although I recognize it's not a 100% chance because it's possible the long tail of self-driving problems winds up being an AGI complete problem. I think there's plenty of value to mine out of it with narrow AI, and I think that it's going to happen probably more so than people expect. But it's that whole sigmoid curve where you overestimate the near-term progress and you underestimate the long-term progress. And I think self-driving is going to be like that. And I think 2030 is still a pretty good bet.
Yeah, unfortunately, self-driving is a problem that is safety critical, meaning that if you don't do it well, people get hurt.
But the other side of that is people are terrible drivers. So it is not going to be, that's probably going to be the argument that gets it through is like, we can save 10,000 lives a year by taking imperfect self-driving cars and letting them take over a lot of driving responsibilities. It's was it 30,000 people a year die in auto accidents right now in America? And a lot of those are preventable. And the problem is you'll have people that every time a Tesla crashes into something, you've got a bunch of people that literally have vested interest shorting Tesla to come out and make it the worst thing in the world. And people will be fighting against that. But optimist in me again, I think that we will have systems that are statistically safer than human drivers, and we will be saving thousands and thousands of lives every year when we can hand over more of those responsibilities to it.
I do still think, as a person who studied this problem very deeply from a human side as well, it's still an open problem how good/bad humans are at driving. It's a kind of funny thing we say about each other. Oh, humans suck at driving. Everybody except you, of course. Like, we think we're good at driving. But after really studying it, I think you start to notice, because I've watched hundreds of hours of humans driving with the projects of this kind of thing. You've noticed that even with the distraction, even with everything else, humans are able to do some incredible things with the attention, even when you're just looking at the smartphone, just to get cues from the environment, to make last seconds decisions, to use instinctual type of decisions that actually save your ass time and time and time again, and are able to do that with so much uncertainty around you in such tricky dynamic environments. I don't know exactly how hard is it to beat that kind of skill of common sense reasoning.
So this is one of those interesting things that there have been a lot of studies about how experts in their field usually underestimate the progress that's going to happen because an expert thinks about all the problems they deal with. And they're like, damn, I'm going to have a hard time solving all of this. And they filter out the fact that they are one expert in a field of thousands. And, you think about, I can't do all of that. And you sometimes forget about the scope of the ecosystem that you're embedded in. And if you think back 8 years, very specifically, the state of AI and machine learning, where was that we had just gotten ResNets probably at that point. And you look at all the amazing magical things that have happened in 8 years. And they do kind of seem to be happening a little faster in recent years also. And you project that 8 more years into the future, where, again, I think there's a 50% chance we're going to have signs of life of AGI, which we can put through driver's ed if we need to actually build self-driving cars. And I think that the narrow systems are going to have real value demonstrated well before then.
So signs of life in AGI, you've mentioned that. Okay, first of all, you're one of the most brilliant people on this earth. You could be solving a number of different problems, as you've mentioned. Your mind was attracted to nuclear energy. Obviously, virtual reality with the metaverse is something you could have a tremendous impact on.
So I do want to say a quick thing about nuclear energy, where this is something that this so precisely feels like aerospace before SpaceX, where from everything that I know about all of these, the physics of this stuff hasn't changed, and the reasons why things are expensive now are not fundamental. Somebody should be going into really hard Elon Musk style at fission, economical fission, not fusion, where the fusion is the kind of the darling of people that want to go and do nuclear because it doesn't have the taint that fission has in a lot of people's minds. But it's an almost absurdly complex thing where nuclear fusion is, you look at the tokamak